Hi, welcome to lesson 3 of arc sectors and angles and circles. Today we will be looking at finding the area of a sector. But firstly, we will do a couple of questions to start with. Remember, where you see the notepad and pencil icon in the top right hand corner, please pause the video and copy the notes and examples into your jotter or complete the exercise at the end of the slides. So pause the video now and have a go at both of these questions, please. Okay, let's look at example A. Here we have a circle with a diameter of 19 metres and we are asked to find the area of each circle below. So if the diameter is 90 metres, then the radius is half of this, which is 9.5 metres. The area of a circle, remember, is pi times r squared. So that would be pi times 9.5 times 9.5. Or if you have a scientific calculator with a squared button on it, you can put this in as pi times 9.5 squared. And that will give you an overall area of 283.5 square metres for the circle. Example B, this time we have a circle with a radius of 3.6 centimetres. So if the radius is 3.6, then the diameter would be double, which is 7.2. But we're being asked to find the area, so it's still pi times r squared, so it's still pi times 3.6 times 3.6, or alternatively pi times 3.6 squared on your scientific calculator, which overall will give us an area of 40.7 square centimetres for the area of the pale blue circle. Okay, so today's lesson we are going to be looking at calculating the area of a sector. By the end of the lesson we should be able to identify a sector, know the sector formula and be able to calculate the sector area with appropriate working in units. So firstly, what is a sector? Well, a sector is a fraction of the area of the circle. We can see this from the green slice on the diagram. This sector is called AOB. X is still the angle at the centre, and if X is less than 180 degrees, a minor sector is created and it looks a bit like a slice of pizza. If X is greater than 180 degrees, then a major sector is created and this looks a bit like Pac-Man. So now we're going to look at how we actually find the area of a sector. So we said in the previous slide that the sector is a fraction of the area, but we know from BODMAS that of equals times, so we can rewrite this as the sector equals a fraction times the area. And remember, the area of the circle is pi r squared. The fraction is obtained in exactly the same way as before. It's the angle at the centre over 360 degrees. So let's look at the example. We're asked to find the area of the minor sector XOY in a circle with a radius of 6 centimetres and an angle at the centre of 45 degrees. So our sector formula is sector equals fraction times area. So sector XOY is our fraction times pi r squared. If we put the values in, that will be 45 divided by 360 times pi times the radius of 6 squared. And we get an overall answer of 14.1 square centimetres when we put that into the calculator. Let's look at a second example. Here we have a circle with a radius of 9 centimetres and an angle at the centre of 60 degrees. The question says, find the area of sector AOB. Now, if you notice, the word major or minor is not used here, in which case we just use the angle given. So in this case, we will be finding a minor sector. The radius is 9 centimetres. Our formula is a sector is a fraction times the area. So the sector is our fraction times pi r squared. And if we put in our values, that becomes 60 divided by 360 times pi times the radius of 9 squared. And we get a final answer of 42.41 square centimetres for the area of the green sector. Let's look at a third and final example. Here we're asked to find the area of the major sector POQ in a circle with a radius of 10 metres and a minor angle at the centre of 100 degrees. But to find the major sector, we need to use the major angle at the centre. So we need to do 360 take away 100 is equal to 260 degrees. So the major angle in the green sector is 260 degrees. The radius is 10 metres, and the formula sector equals a fraction times our area. So our major sector POQ is our fraction times pi r squared, and if we put in our values, that's 260 divided by 360 times pi times the radius of 10 squared, and that will give us an overall area of the green sector of 226.9 square metres. Now it's your turn. So in the exercise that follows, please answer all the questions into your class jotter. Remember your formula, sum, and answers with units, and then check and correct your work at the end. If you have any issues, just post a message. Here goes.